Question number 6. So the diagram on the right shows a tissue box with a square base of sides x centimeter and height of 10 centimeter. So A, write the base area of the box A as a function of x and its volume as a function of A. So for the part A here, so the base of our tissue box here is in the shape of square with the sides of x centimeter. So the area can be found by multiplying the x with the x here. So in this case, our A here will have an input of x. So A maps x to x squared. So this is the base area of the box as a function of x, as you have x as your object. And for the part of volumes, so if you look at here, the volume is in the shape of cuboids. So to find the volumes, so we are going to multiply x with the x, which is equal to the base area, and then multiply by the height. So x squared multiplied by 10, which is equal to 10x squared. Now in this case, our volume will have x as our object. So v maps x to 10x squared. So this v is as a function of x. But the question's asking you to state the volume as a function of A, which means we need to have A as our object for the volume. So the x squared here for the volume. So for the area, we also have the x squared. So the x squared is actually equal to A, which is the area. So I can substitute the x squared with the A. By doing so, so this volume is as a function of A. Now for the part of questions B, show that the volume V is the result of the compositions of these two functions. So we have two functions, which is the A and the V. So the composition of these two functions is the composite functions. So from here we can replace the x squared with the A, which means we can have the composite functions of VA. So by inserting the functions A into the functions V, so the A is our x squared. So we can insert this x squared into the A in our functions V, which you're going to have 10x squared. So 10x squared is the same as the parts that you find here. So this composite functions VA is the volume, as it is the same as the one that you find in A. Or I can replace the x squared here with the A, right? So this 10A is also the same as the volume that you find in the questions A. So these compositions of VA is the volume of the tissue box. Question 7. The function f is defined by f maps x to x plus 6. So find the function g in each of the following. So a, b, c is all the composite function of f, g or gf. So function f has been given, so you need to find what is the function g. So let us start with questions A. So the composite functions fg maps x to 2x squared minus 3x minus 7. So if you look at the positions of the g in our composite functions fg, this is the inner one. So you can find the g quite straightforward. So fg is formed when you insert the function g into the function f. Then it will give you the answer of 2x squared minus 3x minus 7. We didn't know what is the g, but we know that we're going to insert this function g into the x in our function f. So we're going to substitute the x here with gx. So gx plus 6 equal to 2x squared minus 3x minus 7. To find the g, so we're going to move this plus 6 to the other sides. So 2x squared minus 3x minus 7 minus 6. So solve for the like term, in this case, which is the number negative 7 minus 6, so it's going to be minus 13. So that is the functions of g in the case A here. Now let us move to questions B. So questions B, we have a composite functions of gf maps x to x squared plus 4. Now if you look at the g in our composite functions, this is the outer one. So to solve for the g, we need to use the inverse functions. So this gf is formed when you have the functions f, you insert it into the function g. Then it's going to give you the answer of x squared plus 4. Function fx already given, which is x plus 6. But we didn't have the g, so we didn't know this x plus 6. We need to insert it way in the functions g. So to move from here, we need to use the inverse functions. So let's y equal to x plus 6. So to find the inverse, let's the x to become the subject of the formula. So we're going to move this plus 6 to the other side. So x is equal to y minus 6. So this is the inverse functions. So let us continue. So we're going to continue from here. So now this x plus 6, we're going to replace it with y. So gy equal to, and this x here, we're going to replace it with the inverse functions here, y minus 6. So therefore, we're going to have brackets y minus 6 squared plus 4. So here it means you're going to have two brackets of y minus 6 plus 4. To solve this, then you need to expand it. So after you expand it, you're going to have y squared minus 6y, another minus 6y, so total you have minus 12y plus 36 plus 6. So solve for the like terms, so y squared minus 12y plus 40. So this is the functions of g with an object of y. So if you want to find the g with an object of x, then we're going to replace the y that we have here with x as well. So there you have it. So this is the functions of g in the case of B here. So now let us move to the question C. We also have the composite function gf, which map x to at minus x. So if you look at the positions of g, this is the outer one, so we're going to solve it using the same method as the questions B. So it is formed when you insert the function f into the function g. So function f we know, which is x plus 6 here. Now from here we need to find the inverse functions. As in this case, our function f is the same, so therefore you're going to have the same inverse functions here. So we're going to just use the inverse function that we find in questions B to solve for the C. So from here, this x plus 6, we're going to replace it with y. And the x here, we're going to replace it with the y minus 6. So you're going to have at minus, so the x here, put a bracket and replace it with y minus 6. So you're going to have at minus, so this is the same as you expand it, so you're going to have minus y plus 6. So 8 plus 6, you have 14 minus y. So this is the function g as a function of y with an input of y. So if you want to find g with an input of x, then we're going to replace the y with the letter x. So this is the function g for the question C. So question number 8, so the diagram on the right show the relations between set P, set Q and set R. Given that the set P maps to set Q by the functions x minus 1 over 3 and maps to set R by the composite functions fg, maps x to x squared minus 3x plus 6. So the question A, write the functions that map set P to set Q by using the functions notations. Now from the questions here, we know that the functions that map P to Q is x minus 1 over 3. And we are given a composite functions of fg. So when you have a composite functions of fg, so the order is this function g, the inner one, you are going to do it first, then followed by the functions f. So therefore, the functions that map P to Q will be the first one, which is equal to g. And the functions that map set Q to R will be the second one, which is the functions f. So for the questions A, we want to write the functions notations. So we know that the functions is functions g. So you can write it g dot x with an arrow. So x minus 1 over 3. Or you can also write it in g bracket x equal to x minus 1 over 3. So there you have it, the functions notation for the g. Now we're going to move to the questions B. So find the functions that map set Q to R. So in this case, the question asking you to find the functions f. So the composite functions fg has been given to you. So one of the functions, which is the g, has been given, so you need to find the f. So if we look at the positions of the f in our composite function, it is the outer one, right? So you're going to find this using the inverse functions method. So this composite function is formed when you insert the function g into the f. Now function g is this one, x minus 1 over 3. Now from here, we're going to find the inverse functions. So let's y equal to x minus 1 over 3. So to find the inverse functions here, we're going to let the x to become our subject of the formula. So therefore, we're going to move this 3 to the other side. So 3y equal to x minus 1. So we're going to, later on, we're going to move this negative 1 to the front. So x is equal to 3y plus 1. So now let us continue. Now from here, this x minus 1 over 3, here we're going to replace it with the y. And the x that we have here, we're going to replace it with 3y plus 1. So you're going to have bracket 3y plus 1 square minus 3 bracket 3y plus 1 plus 6. So for the first part here, this 3y plus 1, this bracket exists 2 times. And for this part, you can expand it straight away. So you're going to have negative 9y minus 3 plus 6. So for this part, you are going to expand it as well. So you're going to have 9y squared. So combine this together, 3y plus 3y. So you're going to have 6y plus 1 minus 9y. So here, solve it, you're going to have a positive 3. So later on, we're going to solve for the like terms. So this 6y will be with this minus 9y. So you're going to have minus 3y, and then this plus 1 plus 3 you're going to have plus 4. So this is the functions y, function f with an object of y. So to find it in the function using with an object of x, then we're going to replace all the y here with the letter x. So there you have it, the functions f. Question 9. So given f maps x to px plus q and f cube maps x to at x plus minus 7. So A, find the value of p and q. So this f cube is formed from this function f here. So when you insert the function f into the function f 3 times, then you're going to have the f cube. Then to find the p and q, then we're going to do the comparison. So for the part A here, we're going to start to find the f square first. So f square is formed when you insert the function f into the function f. So the function f here is given px plus q. So this is the one that we're going to insert into the x in our function f. Therefore, you're going to have p bracket px plus q plus q. So for this part, you're going to expand it. Then you're going to have p square x plus pq plus q. So this is the part for f square. Then for f cube, you can find it by inserting the f square into the functions f. So f square, we already find it here, which is the p square x plus pq plus q. So this is the one that we're going to insert into the x in our function f. So we're going to have p bracket p square x plus pq plus q plus q. So this part also you're going to expand it. So you're going to have p cube x plus p square q plus pq plus q. So this is the iterative functions f cubed. Now we are going to find what is the value of p and q by doing the comparisons. So from the information given here, this number 8 is the coefficients for the x, and when you compare it to the f cube that we find here, the coefficients for the x here is the p cube. So by doing the comparisons, so we found that p cube is equal to 8. To find the p, move this cube to the other side, so we get cube root of 8. It will give you the answer of 2. So therefore p is equal to 2. Now for the other parts, which is the p square q plus pq plus q here, it is equal to this negative 7. Now as we know the p is equal to 2, here we can replace the p with 2 straight away in order for us to find the q. So for the p here, we're going to replace it with 2. So you're going to have 2 square q plus 2q plus q equal to negative 7. So 2 square is 4 plus 2 plus 1, you're going to have 7q equal to negative 7. So q is equal to negative 7 divided by 7, which will give you the answer of negative 1. So that is for the part A. Now for the part B, determine the function of f4. So you can find the function f4 by inserting the f cube into the function f. So from the question here, you already know that f cube is equal to at x minus 7. So this is the one that we're going to insert into the function f. Now for the function f, as we already know what is the p and q, So from here we can replace the p with the value of 2, and we can replace the q here with -1. So therefore you're going to have fx, which is equal to 2x minus 1. So this at x minus 7, we're going to replace it at the x in our functions f here. So 2 bracket at x minus 7 minus 1. So expand this, you're going to have 16x minus 14 minus 1. So finally, you're going to have 16x minus 15. So that is for the f4. So C, by studying the patterns of f squared, f cubed, and f4, determine the general rule fn, where n is the number of time. So for the part C here, so I'm going to write all of the functions here for us to see the patterns easily. So fx, after you insert the p, 2, q, -1 into it, you're going to have 2x minus 1. And for the f squared, so after you insert the p here with 2, and the q here with -1, -1, so you're going to have 4x minus 3. And for f cubed, you're going to have at x minus 7, and f4 is 16x minus 15. So now we're going to find the patterns. So first, let us look at the coefficients for the x. This is all the multiplications of multiples of 2, right? So we can write it in the power of 2. So this number 2 is 2 power of 1. Number 4 is 2 to the power of 2. Add is 2 to the power of 3. And 16 is 2 to the power of 4. So that is the patterns that we find here. And for the numbers at the back here, 1, 3, 7, 15. This number is always less 1 from the coefficients of the x here, right? So therefore, for this number 1 here, we can write it as 2 to the power of 1 minus 1. And for this 3 is 2 to the power of 2 minus 1. 7 is 2 to the power of 3 minus 1. And for this 15 is 2 to the power of 4 minus 1. Now for us to determine the general rule, so I'm going to write it here. So the general rule of fn. So the number that didn't change, we're just going to copy, and the power, which is changing here from 1, 2, 3, 4 here, we're going to replace it with n. So therefore, you're going to have 2n x minus, so this part, so put the brackets to it, 2n minus 1. So if I expand this, you're going to have 2n x minus 2n plus 1. So that is the general rule for the questions C. Question number 10. So a car factory manufactures n car daily after t hours of operation is given by n maps t to 100t minus 5t squared. So t is the hours, so in between 0 to 10. If the cost in Rm for manufacturing x car is Cn equal to 15,000 plus 8,000x, find the cost C as a function of times t for the operations of the factory. Now look at this function C that we have here. This is as a function of x. So the x here is the number of cars. So the number of cars produced after t hours is the n cars, right? So this number of car, n car after t hours, is represented by this 100t minus 5t squared. So if I want to find the cost as a function of times, it means I'm going to substitute the x here with 100t minus 5t squared. Therefore, you're going to insert the function n into the function c. So you're going to find the composite functions of Cn. as the functions of time. So the composite function Cn is formed when you insert the functions n into the functions c. So the functions n is 100t minus 5t squared. So this is the one that you're going to insert the n's here. So next you're going to have 15,000 plus 8,000. So the x here we're going to replace it with 100t minus 5t squared. So we're going to expand for this part. So here you're going to have 40,000 t squared. So this is the cos c as the functions of time.